Okay, this is how I calculated, well, verified his calculations. If you can see the cursor, we've got, well, let me just do this. Here's the first gear, and that's its what's the name? That's its RPM. And then that one spins this yellow gear, and its RPM is this, which is just a formula, B5, which is that, divided by 4, okay, which gives that. Then from the yellow gear goes through to this green gear. Its R1 is this, and its formula there is B22, which is down here, divided by 4. And so on. So then the green one turns this blue one. That's its RPM there. That's its formula. And we carry on through the whole cycle. Chicka, 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 till this last gear here, this blue one. And its rotational speed is 7.5 times 10 to the minus 11 RPM. Okay, if we come up here, if we invert that, then we get, instead of RPM, we get minutes per revolution, which is this large number here. Large amount of minutes per one revolution. If we divide that by 60, we get the hours. If we divide how many hours in a day, 24, divide that by 24, we get the amount of days. And then if we divide that by the amount of days in a year, 365 and a quarter, we get 25,243 years. And you can see that if we change the input to a very high speed, like say 242,000 RPM, that would update all the values, and it would still only get done in 552 years.